Hi everyone. Today we are going to explain the exponential graphs. And if you remember well, that we explained in the previous session the parabola graphs. So what is the difference between them? So normally it is about the graphs. All the graphs are different. So what we mean by exponential graphs? So what is the corresponding function to the exponential graphs? First of all, we should know that the general form of an exponential graph is y equal to k power x. So where k and a are constant. So k and a are constant. In this course only, we are talking about particular cases where k is just the sign, +1 or -1. So +1 or -1, we mean the sign of a power x. So good. So let's find out what are the difference or how the graph is affected when a is given differently with different numbers. So we can remark it clearly from this graph. The red is for the graph of the function y equal to 2 power x. We read the black one is the graph of the function y equal to 5 power x. So we can remark clearly when a is greater. So when we have a greater a, okay. So normally the function becomes steeper. Steeper, I mean with a greater slope. So normally we can remark, for example, for 1, we have a 2 as the image when y equal to 2x, whereas we have a 5 as image when y equal to 5x steeper. So normally the y become bigger, okay, rapidly. Good. And this one for y equal to 0.5x, y equal to 0.5x. So y for example, when x equal to 0, for all these graphs for x equal to 0, we know that a, whatever is a, when we have the exponent equal to 0 equal to 1. So the images for all these graphs, for all these functions, when x equal to 0, all the images or all the ordinates of this point equal to 1. Okay? Good. But I think for this one, we have a mistake. We will find out the mistake later. I think we have a minus 0.5x. Normally, we'll find out. Okay, next. First of all, in the first exercise, we have complete this table of value for y equal to 2x. So when x equal to -3, when x equal to -2, when x equal to -1. And I mentioned before, when x equal to 0, we have 2 power 0, we have a 1. Okay, and so on. So normally when x equal to -3, we can use the calculator to calculate the corresponding ordinate 0.125. For x equal to -2, 0.25 is the image, and so on. So when x equal to 4, we have a 2 power 4. 2 power 4, or 2 exponent 4, 2 by 2 by 2 by 2, so we'll obtain 16. We put all these couples, -3, 0. -2, 0.25, -1, 0.5, 0, 1, 1, 2, and so on. We put all these graphs here, okay? To obtain finally this graph, and if we join all these particular points given by the table, in this table, we will obtain these points, and we join it to obtain this increasing graph. How to say that it is increasing? We study each graph from left to right. So from left to right, we can remark clearly that this curve is increasing with respect to the y values. Okay, so actually I made a mistake here. So normally it is 0, like 0.5. It is like, yes, 0.5 power x, because when the a is smaller than 1, when a is smaller than 1, it's positive. We are talking about a positive a. Between the a is between 0 and 1, 0.5, 0.2. So normally we have an opposite curve to form of curves. For example, we have an increasing. So when a is between 0 and 1, we will obtain a decreasing value, decreasing curve. Why? Because, 0.5, if we put an exponent negative, for example, -4, okay, we know that 0.5, it is like fraction, y over 2, for example, y over 2, and we obtain -4. We know that the negative exponent reverses these positions. So we'll obtain like 2 over 1 power 4. So we'll obtain a 16 over 1. 1 power 4 is 1, so 16. So we have a greater value when a is between 0 and 1. We have a decreasing curve. So it is all true. It's all true. Okay? Let's continue. They ask us what happens to value of y as x gets larger. It is very easy to say when x gets larger, y gets larger also. Okay. When x is gets smaller. So when x gets smaller, like how to say when x gets larger in this way, and that when x gets smaller in this way, we find that the value of y gets closer, decreases, and gets closer to the x-axis. What we mean by the x-axis? The equation of the x-axis is equal to y equal to 0. Okay, so normally when x get closer, as we said, so y decreases and get closer to the y-axis. And when it gets closer to the x-axis and but doesn't cross it, so we say it is a asymptote. So an asymptote is a straight line that a curve approaches but does not cross. Normally, when x increases, we saw that the graph increases. So normally the value of y increases as well. When x decreases, when we go from right to left, okay, in the extreme of the left, so normally we saw that the graph approaches to the x-axis and doesn't cross it. So normally it is the asymptote. So because, by definition, as we said, an asymptote is a straight line that the curve approaches but does not cross. So normally it is the x-axis with an equation y equal to 0. Easy. This is very easy. Normally, this is the a graph of the function y equal to 2 power x. So normally, if we deal with another exponential function y 3x, so when a increases, So normally what's happening? First of all, we should know that when A increases and A is greater than 1, so normally we'll obtain a steeper graph. So another example, when y equal to 5x and y equal to 3x. So normally the graph of y equal to 5x is steeper than y equal to 3x. What we mean by steeper? So normally there's when y equal to like we'll obtain this graph here. So we will obtain another graph but steeper like that. Okay, good. So if we take another form of the exponential function with the minus x, so we want to know what the difference between the graph equal 1, y equal to 2x, and the y equal to 2 minus x. Y equal to 2x because the 2 is greater than 1, as I said before. So normally 2x, so it is like increasing function. So it is like increasing function. When y equal to 2, when y equal to 0, it is a 1. When y equal to 1, it is a 2, and so on. Normally it is like that. Okay, it's not exactly, but it is like that. Good. So what is the graph for y equal to 2 minus x? So we can write it in another way because the exponent is minus. So like we have 2 minus 1 power x, because we know the property of exponents. So we have directly 2 consecutive exponents, so we multiply them. So minus x, minus 1 by x is minus x. What we mean by 2 power minus 1, it is like 1 over 2 power 1, like 1 over 2. 1 over 2, it is a number, it is a smaller than 1. So normally we have a decreasing graph curve, as we mentioned before. It is normally like the study of the graph, or the form of the graph is directly related to the value of a. So normally, what are the difference between 2 minus x and 2x? We have two graphs mirror of each other with respect to the y-axis. Good. So it is a like reflection of y equal to 2x in the y-axis. So good. All these interpretation are related to the graph given above. So normally we have here minus 2x. This is like different between them. So we have a 2x, and we know that 2x is like that. Okay, y equal to 2x. 2 power x. The other exponential function minus 2x. If k equal to minus 1, so what is the difference? So if if instead of x we have a minus x, normally we have the same but the reflection with respect to the y-axis. Okay, so if we have, instead of all these, we have a y equal to minus 2 power x. So normally we have a 2 power x, the same this, but minus. What we mean by minus? So this number, it is reflected to the x-axis, reflected to the x-axis, reflected to the x. Each point is reflected to the x-axis. Each point is reflected to the x-axis to obtain a reflection to the x-axis. So we obtain the same graph, but reflected to the x-axis. So it is a reflection of y equal to x in the x-axis, and so on. So easy. So, but here we have a combination of two. We have a minus 2 minus x. Okay. So normally, if we want to compare this graph with minus this one? First of all, because they have 2 power minus x. Okay. So normally a here is between 0 and 1. So it is a decreasing. So normally this one is a decreasing value. It's a decreasing curve. The curve representative of this graph is decreasing. Okay, decreasing, we mean from left to right is decreasing like that, decreasing. And when we have minus 2 power minus x, so it is like a reflection with respect to the x-axis. So good. The one we can reflect each point here, each point here, each point to obtain the reflection, the good reflection with which is this red curve. It is a reflection of I equal to 2 power minus x in y-axis and the x-axis, and so on. So it is easy, easy, easy. How to find by trial and error, for example, or to solve an equation given by exponential function. So for example, we have a y equal to 5x. And we have with y coordinate equal 125 and want to find x. How? The only solution here is to use to be explained in this course as given by trial and error. How? We use different values of x, and we try to find 125. So for example, we take x equal to 2. 5 power 2, it is a 5 by 5, 25. 25 is very, very too small comparing with 125. So we go to use another value, but greater than 2. X equal to 5, for example. 5 power 5 is 3,000. 125 is too large. So then 5 is too large because we are bigger. We are far away from 125. So we use another value but smaller than 5, so and greater than 2. So we take 3. 5 power 3 is equal to 25. So we hit our goal. Then x equal to 3 is our solution. And the solution of the equation y equal to 5x when y equal to 125. These are the important ideas of this course, of this lecture. Thank you for listening and have a nice day.